Our first presenter in the security track is Joe Klein. Joe is very well known in the IPv6 community, been around for a very long time, done a lot of work and original research on IPv6. I think you've been involved with security longer than I've been alive, but that's
30 years, yeah.
But he's got quite a bit of background. He's done some really interesting things, and if you get a chance, he's done quite a few presentations. A lot of them are up on YouTube for the GoGoNet events and things like that. If you get the opportunity, he covers a wide breadth of subject matter. I think it's definitely worth your time to go check those out. He also holds some patents, some patent pendings,
yeah.
and I think those are worth an opportunity to talk to Joe about what's going on with that. And with that, I'm probably just going to let you dive straight into it, if you're okay with that.
Perfect. Close this down. So I was delayed discussing the security implications of the Internet of Things and non-obvious issues with some friends. So I'm Joe Klein. Actually got into the IPv4 or the IPv6 world about 14 years ago. I was having some time with the late Jim Bound and Vince Cerf, and I showed him how I broke something in IPv6, and Jim Bound, in his typical attitude, he says, "That's evil. Help us fix IPv6." So for 14 years, for a while, all I was doing is breaking it, but now I'm trying to actually figure out what is broken so we can actually fix it. This particular talk comes from working with a bunch of security operations centers early and late in the environment. This is, let's see, scheduled for 45 minutes. The whole reason I'm doing this is most SOCs forget that IPv6 has been around. We're going to talk about that, and they're ignoring it. And I put this presentation together specifically for several clients so that they can understand what the implication and risks are, so they can kind of figure out how to fix it, hopefully. Let's talk about the deployment first. So back in 2005, I was talking to Govy guy, Chris Strands, and while we were talking about deployment, he was talking to me and said, you know, the security products are the long pole and the long tent pole, just like we heard earlier today. And it still is. Bob Gurley basically said that based on his testing, and he's a well-known consultant in this space, that the products are still the reason people are holding back. And one thing I haven't mentioned is for the last 10 years, I go to Black Hat and DEF CON, many conferences, speaking and attending. I have been walking around and doing a survey of every vendor in every booth, asking them IPv6 questions. The first actually 4 years, it was asking a question, do you support IPv6? And they thought it was like a, layer 7 application. Then they started claiming that they did it. And then I started asking harder questions. This year, this was the most common quote that I was getting, which was, hey, we support IPv6. We just took the database field and we went from 32 bits to 128 bits. That's all there is to it, right? Now we can say we support IPv6. This is so common in the community right now. It's very frustrating for me being a security guy, being a guy that's done pen testing and red teaming for years and years. This is great for me, but, big problem. So we're after lunch, so I figure I'd, change the topic a little bit to get you guys a little bit concerned about where this talk is going. So a unicorn is a mythical animal representing a horse. It's something that we feel warm and fuzzy about. Well, then we have something in the security field that's is being used called rainbows and unicorns. It's really a serious incident or an unfortunate experience. And then we have rainbows, butterflies, and unicorns. So you see this acronym a lot with Security Operations Center people, and that's basically where you pretty much have to deal with it and grin and bear it. Okay? And this is going to have a big influence over everything we're dealing with. So, security. Guess what security is? This is a definition for security. It's that warm and fuzzy thing. not real measurable, nothing we can do anything with. Cybersecurity, yes, I hate to use the word cybersecurity, and in some communities this is a drinking game to use that word. So people get very drunk when you say that. So if anybody's playing this, I'll say it at least 30 more times because you'll have fun. So it's really about measuring the protection and taking measures to protect the systems and the networks from attacks, DDoSs, unauthorized access. For the defense people, or for the offense people, the guys that are doing red teams and such, we know this is unicorns. We always get in. I've been getting in for 30 years when I get pointed at something. Okay? This is a real concern for me. The operations people, this is a grin and bear it movement. Basically, they have to deal with these kind of incidents. I guess you saw the Bourne Shell vulnerability that got released this morning on a Twitter. Already somebody scanned the whole internet, has already started compromising those systems. We talked about less than an hour systems became compromised once that vulnerability was disclosed. Okay? So we're talking the op tempo of the attackers are faster. Therefore, the guys in defense have to just grin and bear it and deal with these magnificent failures. So definition of a SOC basically provides those measures of protections against your systems. On the internet, same thing as, close to cybersecurity. It can be managed in-house or outsourced. As we have seen in the past, a lot of organizations start outsourcing these services when their internal people are not being responsive to changes in the environment. This becomes important later, and I hate it when it does automatic. We also have a 24/7. I hear a lot of people that they have a SOC and they're managing it only during working hours. Well, guess what? Hackers and bad guys, adversaries, go at you 24/7 and on holidays. So, because other adversaries don't have the same holidays. So the question I've been asking for a while, because the slowdown has turned out to be that the SOC has a lot of influence over the security operations of an organization. They basically talk to the auditors. They have influence in the guys that are doing scanning and vulnerabilities and everything else. So I've been asking, two questions. Do you move to a dual stack or IPv6 native, or do you do nothing? Well, up to this point, it's do nothing. We'll talk about why in a minute. So in the next part of this presentation, I'm going to deal with why and how. First thing is, I was just up in New York last week discussing Internet of Things, another buzzword, another drinking game. A lot of organizations, executives are excited about this, gaining new income from untapped markets and untapped capabilities. But many times they're not aware that they have to move to IPv6. And the SOCs, they too are not aware that they have to move to IPv6. Now see the little pink one over to the right side? That's all we manage today. I am now starting to see a trend, and I've talked to Gartner Group and 451 and several others. They're concerned that the SOCs are going to be responsible for managing the security of the Internet of Things against their infrastructure and their people. Cars now have IP addresses. Do you want your executives driving around a car that's unmonitored? How about the health implant? Somebody's going to have to do it. And it's better that the operations center that you have trusted to do this capability is there. Again, these are all being implemented in IPv6. They have to be aware of this issue. Second thing, let's talk about why it's so good to stay with IPv4. And by the way, warning, yes, we're talking about that old protocol. Okay? First issue. Has anybody heard about the BGP routing issues? Is this new to anybody that 5,000 to 10,000 specific routes were injected a few weeks ago and caused outages within routers all around the world that were not configured or not capable of dealing with it? What was the impact to your customer of that? Oh, by the way, Richard Clark from the White House, when he was a cyber czar, he talked about this 10 years ago, that we need to move to IPv6 to resolve this issue. Second thing is we have seen the flaw in the Ethernet drivers, that even Ethernet card companies aren't even looking at this seriously. I've been presenting for many years about flaws I've found in layer 2 products that have yet to be fixed, but they still exist out there. And also packet filtering. How are we actually packet filtering the tunnels today that we have for GRE, for all the other tunnel types? A lot of times we have a limitation on how many packet filters we can deal with. Next thing, security products and tools. The security products and tools in the IPv4 domain have pretty much failed. Malware became, or antivirus became malware, is now called endpoint solutions. When? So a lot of the services and such that are using IPv4 no longer have visibility because you're behind a NAT or a NAT or a NAT. So the operations center doesn't know that some group threw a Linksys router up and put 60 servers behind that, and somebody else in the same building said, hey, I can get access to the corporate network, let me add another one. I was doing a pen test and I actually found, five servers that were 3 levels deep that they had in a closet that nobody knew existed. Pretty fun. Now let's talk about my favorite, CGN, carrier grade NAT. It has some, basically carrier grade NAT is one external address, and you're sharing it with your friends, obviously, anywhere from 1,000 to 10,000 of your friends. You're only allocated so many ports, so applications start breaking. That's kind of a problem. But additionally, the standard actually says that you're not supposed to maintain that IP address for a long period of time. The standard says every 2 minutes. Let's talk about the implications of on your IPv4 SOC. Oops, Intel goes away. Well, why is that? Well, a lot of the people that are implementing carrier grade NAT are consolidating their their IP ranges and their location information to certain locations. I have one vendor that I played with their carrier grade NAT from a hotel because I was bored one day, and found that they had consolidated all their IPv4 addresses to 3 locations, Ashburn, West Coast, and Chicago. Kind of cool because I was actually coming from Jacksonville, Florida. So you no longer can find out where the attackers are from because of this carrier grade NAT issue. Second thing, geolocation. Yeah, we don't have that either. Third, applications break. If you have an application that is written with certain libraries in Java, Python, certain older Microsoft libraries, they don't support multiple NATs. They only support one level of NAT. By the way, this also kills voice over IP applications, IPsec VPNs. This also has a wonderful impact on if you're a game player, and I'm going to play, say, a zombie game with you. Well, that's not good. Deny. If you're playing a zombie game and you're on the same carrier, in some cases I can't play my Xbox against this person on the same carrier. I can only play against somebody else. Does that impact your business model? I don't know. Legal discovery. The NANOG list and other lists are talking about the carriers refuse to log this stuff. So no longer are we logging a source address and a port at a time. Now we have to deal with a source address, port, a destination address, a port, and a time frame. And that time frame can be plus or minus 2 minutes because they shift the CGN every 2 minutes. Okay, so I tested this. Does anybody use blacklists to block bad guys? Okay. Well, I did a study a while back to see how they're influenced by each other, and as one of my tests, is I was at this hotel, another hotel. I spent too much time in hotels. And I decided to port scan someplace that I know that would end up getting me blacklisted. Guess what? Within 2 days, it blacklisted anybody that had that IP address for those 2 minutes. How does that impact your organization? By the way, most of the blacklist providers have a long process to have something removed. Some providers have no process to remove. So essentially, in several cases, that blacklist is still out there. Okay, what if somebody else was to do that to your customer base? You had a large customer base in a geolocation with a specific carrier. What's the impact on your business? They can't get to you. Okay, new challenge. Does anybody use NetFlow for protection? NetFlow? What's the problem with NetFlow if my IP addresses and my ports completely change when I'm being attacked? Can I gain context over this? Do I have that capability of saying this is bad? Will my intrusion detection system see this as the same attack or a fragment of this attack? So this is a real problem with IPv4 today that is slowly creeping into the environment that most SOC engineers are not aware of. And also the outsourced services. What if you're on one of those outsourced services, you're using whatever email remotely, and they didn't upgrade their, router? So it could be impacted by BGP. What's the impact of them if, for their own blacklisting on emailing? What's the impact for your home users who are on a CGN trying to get into that service? Because maybe they can't because that IP address is now blacklisted. So this has a lot of ramifications staying with this whole IPv4 technology. But it gets better. I'm being enthusiastic because you guys aren't. It's after lunch. You guys have all eaten. So this is a timeline. And by the way, everything before 2000 is considered the dark ages, where some of us with gray hair remember. But you don't have any gray hair. 3 major events. We saw the DNS reverse and forwarding being implemented. We saw IPv6 World Day. And we saw the launch day. Very important things. Oh, look. Everything in black is when the operating systems were capable of IPv6, but they were turned on by default. Okay. Was your SOC able to detect this back in 2005? Oh, Microsoft, because they wouldn't do that to you either. You see the arrows? There's 2 really cool arrows where they actually move the product from IPv6 capable until on by default. By the way, these slides will be available on my blog and also through the task force, and call me. So all these products, by the way, do you notice Windows CE was capable of it? It was using 6-to-4 tunneling, which you could attack the device itself. No controls. Oh, Apple. Oh, your mainframe has supported it and default on, because nobody uses mainframes anymore, right? And Cisco. So, the question you have to ask is 3 questions specifically. 1, has your SOC been able to detect IPv6 in your infrastructure, and have your executives been aware of this? The reason I ask is I've noticed that the Verizon report has this big 25% gap where they can't figure out where the attackers came from. And I started asking about, were they using IPv6 capable sensors? And most of them said, no, we don't have those. The second issue, your auditors. All current compliance, including Sarbanes-Oxley, requires testing of all ports and protocols. FISMA, HIPAA, you name it. Have your auditors been performing the audits against dual stack? Third thing, if they haven't, are your compliance valid? Can you say that no, sorry, my Sarbanes-Oxley I just spent $50 million on isn't valid? because they only tested half my network. Okay, these are real concerns, and these issues I've been bringing up to a lot of people in the last year. I've been bringing up a lot personally, but public I've been talking about it. Second thing, I'm always told by the SOC guys, so this last slide really deals with, oh, by the way, IPv6 has been on your network for all these years and you haven't been able to defend against any class attacks. This deals with another issue. Okay, same great green slide. Okay. Oh, wow. We saw a tunnel attack back in 2001. Oh, a second one in 2002. Oh, malware. Using it. Oh, yep. More malware. Tunnels, Teredo, default outbound, allowing you to connect out and in, and you could use the 2 addresses and be able to scan it with 24 bits and be able to drive right in with no firewall, because Microsoft didn't include a firewall in Teredo at that time. Yep, more badness. Yep, rootkit. Yep, more badness. Yep, DDoS. I have others, but they get even more frightening. So the question is, are there really any vulnerabilities that have been disclosed? Well, yes, there is. So have your auditors been testing for these? Are your tools capable, is your SOC capable of actually seeing these and seeing these as a concern, just like you see the IPv4 concerns? I don't know. It's your SOC. So the answer? Let's take a poll. So which should we do? Should we go do nothing, or should we move to a dual stack environment? Can I see hands? Do nothing. Okay, nobody has their hand up. Sir, you have your hand like this. It looks like you're almost there. So I assume everybody else is yes, we've got to do this. So the next question I ask is, they always ask is, so what does this have? What's the value? And I'm just using one specific scenario. A little bit about SOC engineers, analysts. They've got 15-minute cycles. They have to close as many tickets as possible within those 15 minutes. They have to use lots of database queries and other things just to be able to deal with attacks from outside and inside. So let's talk about, again, in one case, if you implement it in a specific way. We can talk about the details later, but I don't have the time for this particular presentation. Let's talk about it. Those are 2 IP addresses. Can anybody tell me if they're on the Bogon list? Which RAR they're coming from? Are they a NAT or an endpoint? Let's see. Is it the last hop? I don't know. How many addresses, how many devices are on that segment? Okay, yes, this is only one of 40 templates depending on the RAR and when their policy changed. I'm using the original policy. By showing them this, they can now understand that very quickly their engineers can eyeball an IP address and go, hey, wait a second, that's not been an allocated address. Wow, that's all for this particular, this is out of Asia versus North America. Why are we seeing this? Hey, this is the actual segment, and I can get other information about the host. I can look at what the carrier is, because you can look up the carrier range. And when you're a SOC engineer and looking at with v6, it becomes really fast versus doing the lookups. And if you do a programming tip, this process typically takes 2 minutes. You can drop the process down to less than a second for a database lookup now, because you don't have the complexity of all the representation. For an internal, so can anybody tell me if that's a NAT device, subnet, last hop router, or the MAC address of the device for v4? Come on, somebody's got to be psychic, and we've got students around here. They have figured it out, right? Well, v6, if we just focus on the last 64 bits, a lot of organizations are saying, wait a second, internally, we want EUI 64. So with EUI 64, very quickly, I can look at that address and know it's an Apple. Why do I know that? Because Apple has 8 frames of MAC addresses, and they're fun to chase on a network. But these are real easy to identify for an organization. And visually, this saves a lot of time for the SOC engineers, so they can get through a lot more incidents. So the next issue I'm usually asked are, what are 4 things I need to do to, and by the way, most of them don't talk to the IPv6 community or the transition community. They come to people like me. They say, what are the 4 things I need to do so I can go to the transition group and tell them, hey, we're thinking about doing this. What do you think? First thing, you have to make a decision from your SOC standpoint. Is it a add to your current IPv4 scripts and everything, or is it a re-engineering for IPv6 and then mapping the IPv4 capabilities into the addressing so that as you start getting off of IPv4 completely, you're prepared. It's a lower cost of operations long term. A lot of organizations are doing the first, just patching it and getting on. But the transition off of IPv6 or to IPv6 only environments for a SOC is going to be very expensive. I estimate it's going to increase their cost 20 or 30% more as they move off than they moved on. Second thing, people need to be trained. So how many of you actually sat down your first day at a computer and had a well-known router company or switch company or somebody actually tell you how the protocol completely worked and how the addressing worked and described all this stuff to you when you put your hands on the keyboard? Anybody? Anybody? Well, nobody did that. We booted it up and we learned through trial and error. And then we started questioning. Some of us started reading RFCs. Yeah, that's interesting. Some of us didn't. Some of us don't understand the way that the operating systems work with applications and other systems. Well, this is very true with SOC engineers. If you take a look at the, to make it easy for everybody, the federal government, U.S. federal government has created something called the National Cybersecurity Workforce Framework. It's been recently updated. I was part of the community to update it to add IPv6. This is a list of people that we identified that understanding something about IPv6 would reduce the operational costs of running a security operations center and running security in general. By the way, help desks are typically not brought into the discussion. We found that when you start giving the IP address and a customer is asked to do an IP config and start describing the MAC, the long address, the help desk people go, no, that's the MAC address. No, it says IP address. It says IPv6. Causes a lot of help desk concerns. Next thing, this is another slide I could talk on hours based on experience. As you were talking, as the folks from Wells Fargo were talking about earlier, do an inventory, but don't just do an inventory on the security devices. Look at all the other devices that are supported devices that you're responsible to monitor or have some other capabilities. One of the things I left out here is the NTP infrastructure. Very funny, a lot of organizations will go to leave their IPv4 infrastructure on. They'll turn IPv4 off on their dual stack, and then they'll have no timing. Therefore, Kerberos dies, database writes fail. It's pretty entertaining to watch. That's one of those, unicorn, rainbow, butterfly moments. So this is really difficult. I found problems with every single one of them. At lunch, I was talking about specific vendors. And like I said, I've been asking these vendors for years. A lot of times friends say, hey, come on over to my lab, and I've got this new blah security device. Can you tell me if it does V6? So we spend some time, we look at it, and we find the problems. And right now, a lot of them don't do what they're supposed to do. Proxy servers and email servers don't have blacklists today. Don't know why. All the vendors have been claiming that they've been doing it for 3 years, but none of them have provided any addresses, which is concerning. Encryption. A lot of organizations early on the internet actually bound their certificates to an IP address, an IPv4 address. kind of fails as far as the capability of moving a certificate, so you have to go look at that. We also have, like I said, everything on the right-hand side, access control, virus monitoring. Can I do it across IPv6? I know some vendors that it's only IPv4, so if you go to a IPv6 environment for a SOC, all of a sudden you have no visibility into this. Let's see, email, patching. So you have all of these logs then going into something, your log server. Now the next question is, how does a log server represent the data? Do they have a full IPv6 address? And do they have the proper compression if they're doing the compression, getting rid of the zeros? And when they transmit it, how's it transmitted? And does the logs management product even know that it's compressed or not compressed? This causes all kind of problems with a lot of products. Then let's go up the stack. A lot of the analytic products right now only do IPv4. They also don't look for cross IPv4, IPv6 products. I've called a lot of the SIM manufacturers on this for many years, and they said, hey, not our problems. Customers aren't asking for it. Lastly is the unified portal. I have seen specific vendors misrepresent, can't show you that yet, have misrepresent the IP address. FFO2 is actually in the last 64 bits, and what was in the last 64 bits is in the first 64 bits. And this basically took a vendor, a well-known vendor, a very large vendor, 2 years to actually get around to fixing this for their customers. You can't do analytics on an address if you don't understand how the addressing is created and how you pull the data. You don't have context. And your analytics statistics don't work without context to the data. And then you have our SOC engineer, because he's real happy because he's getting to go to IPv6, and he's wondering if this is a rainbow butterfly and unicorn moment, or if this is truly a unicorn moment. Go create a SOC. Everybody has old computers sitting around. Put VMware on it. Put VirtualBox on it. I've got on my laptop here, I've got VirtualBox and GNS2, Kali, and VMware. And I actually set up separate networks, and I attack the networks from the same computer so that badness doesn't get out from my laptop. All the products, relatively cheap or free. Kali Linux, it has some IPv6 capabilities for your security guys. I did an analysis of the 680 some products on there. The vast majority of them do IPv6. They don't either communicate across the IPv6 or they can't actually do testing across the IPv6. So big problem. Go look at tools. Things like Scapy. Go look at THC. Go get the security tools out there. Go get Security Onion. It's a good thing to look at from intrusion detection system. It has some IPv6 capabilities. It's missing many things, but at least it gives you an idea, and it's cheap, and you can throw it in the environment to see what can be seen. Also, Microsoft licenses. You do have to test Microsoft boxes because everybody has a Microsoft machine or 2 or 10 or millions in your environment. So you're going to have licenses for your VMs to do the testing in many cases. Set up the security lab for a test for you to just play. Set up a separate one for your dev so you can start developing your tools in your SOC into something that's useful, and also into a test environment so you can separate that process. Replicate your production and your management systems and platforms. Very possible you'll find management tools that break you weren't aware of when you're actually testing in this environment. Security management tools. And again, I won't mention them because, well, they'll be watching the video. Hi, guys. So I'm actually ending early. So some final thoughts. Matthew Rehnquist had this quote from RSA last year, and I think it really deals with the issues of our SOCs. And that is, we manage cybersecurity through either leadership or crisis. The absence of leadership, we're left with crisis and compromise. And we've seen this time and time again for a lot of organizations. So what I'm saying is, don't allow the IPv6 to become your cybersecurity compromise. You know, don't allow the rainbows and unicorns and butterflies moment for your organization. You don't want to be like Target. You don't want to be like the thousands of other companies compromised in the last year. It's just not worth it. The SOC is critical to manage your operation. It provides measurements. One thing I didn't include because I think it was going to be too long. The other issue is your reporting. You're going to have to, especially your executive reporting, a lot of the reporting that goes up to the executives won't include IPv6. A lot of the applications don't understand or have context. So if I am doing report generation of compromises or systems and things like that, I can't actually provide context to say, hey, this was via v4, therefore we need to be focusing on this right now, or I need to get funding, some additional funding for IPv6 security because we weren't able to find this or complete this or solve this particular problem. And boy, did I talk quickly today. And thank you. There is my contact information. That was fun. There is my contact information. Present view. Work for a company called Disrupt 6. I'm a CEO. Used to be a geek. Pretty scary. Any questions? Microphone questions? This is where you get to ask the hard ones. You've got me here for a few minutes. That's a quiet microphone.
Testing. There we go. Sort of an observation, sort of a question. I've heard from some of the security analysts of late that they're starting to see a lot of use of dual stack to do obfuscation, where you come in on one protocol, go out another, which I think would encourage people to see dual stack as just a transition mechanism and not an end state we want to be in. Just kind of curious what you're seeing about dual stack specifically for security concerns as opposed to native 6.
Yeah, when I do consulting, that's a big thing I discuss is a lot of the applications don't go across. The SIMs is an example. They have context across IPv4. And they have context across IPv6, but because you have no address association with the source address, the privacy address, the inbound address, whatever it is with the IPv4, and also the multicast and broadcast addresses, the multicast on v6 and the broadcast address on v4, unless they have context that this is the same exact machine being compromised and understand that all this traffic went into this and now I'm seeing it used as a pivot point, yes, definitely. Matter of fact, the current methods being used is phishing. They're embedding IPv6 addresses because the phishing filters don't see IPv6. It gets into your environment, you click it. Depending on which operating system you're using, some of them will enable Teredo directly. You tell it where to go, you tell it what port, use that to come into the environment. You then use that as your foothold, and then you attack via v4 and v6 to maintain a foothold. Matter of fact, Metasploit last year, 2 years ago, included that particular feature. So literally, this is a process where somebody can sit down and press a button to have this occur and use Teredo as a reverse tunnel and to maintain that IPv6 tunnel out there on a regular basis. So yes, I'm seeing this. It's in the tools. It's not being taught. It's not being detected or protected against. Sorry, didn't want to, burst your unicorn.
Thank you, Joe, for a great presentation, great information. I'm curious about behavioral analysis or maybe DLP, intrusion detection, that is actually working for IPv6. Is there anybody actually doing implementation?
The challenges right now, everybody's going to, all the major vendors are focused on signature or regex-based assessments. So as an example, if I'm looking for an embedded IP address in it, I have to also look down maybe a chain of extension headers and fragmented extension headers to be able to find it. There are some IDSs that still can't solve that problem after you get above 2 or 3. So there's a tool called Frag Router that's really fun, used on the pen testing side, where we do that in IPv6. Therefore, I can get around pretty much all the IDSs quickly. The behavior-based systems, I'm putting one together, but it's a little bit too early. Contact me or give me a card and I'll contact you in about 2 months and we'll talk about it. I haven't seen a lot of other people focused on the IPv6 domain. One of the problems I'm finding, again, is some of the products, because they have to make a business decision. I understand this. Their decision is, do I take IPv4 and add IPv6 features to it and deal with the dependencies in the libraries and everything else, or do I start anew with an IPv6 only environment and start coding for it? Okay, I'm not seeing anybody thinking about that at this point, and that's been a long game concern that I've had. Does that answer your question?
Yes,
Any other questions?
Hey, on some presentations, I actually put a picture of Vince Cerf, and I thank him for all the work that we've all gotten out of this particular field. I didn't include it this time. Any other questions? Talk about email, proxies, SSH.
Someone has to have a question.
Web applications, some of the problems with web applications. Your developers embed IPv4 addresses a lot of time in your web applications. They also, based on the age of the library and which library they use at their web application, specifically older Ruby libraries, Python, whatever, they may not represent the address appropriately, and they can make wrong decisions. As an example, hey, this is a Microsoft box, but it's coming from this address, and it will assume it's an IPv4 address and cut the 96 bits off. So you get really strange addresses out of it. And we've seen this, and I've talked about this for years. I'm still seeing this with different web applications when I've come in and done troubleshooting against them.
Any other additional questions?
Next time I'll do a demo and show things breaking and fixing, huh?
So Joe, I had a question for you.
Please.
In regards to deployment recommendations, because
yes,
let's talk about practical stuff, deployment recommendations for folks. What do you think is really sort of the key criteria for transition technologies, and what do you think are the challenges with older systems that are still at RFC 3484 versus 6724? And
I was going to leave the last the presenter not right after me, but the second one. His presentation is going to be about discussing that. We have seen 3, arguably 4 major rewrites in the RFCs, where the RFCs have been tuned for different capabilities. This is a big concern because you may end up having an Internet of Things company that's using the first generation from the dark ages of it, the IPv6 infrastructure, when they're actually supposed to be implementing the current 3 and/or 4. Again, there's arguments which one it is. It becomes a problem to actually identify that, which products can support. As an example, there's nuances in certain operating systems. You can tell which version they're coming from based on how they request addresses, how they do certain transition issues. That's real important. The big thing for a security operations center is the security operations center needs to know what addressing mechanisms they're using throughout the environment, and have access to that through not a spreadsheet, an IPAM address management tool. We're still seeing a lot of SOCs trying to do this with spreadsheets or their own database that doesn't support it and can't provide live information. The second thing, they need to know which transition mechanisms are being used so they can understand the security risks, so they can come around and figure out how to detect it, which again is a big issue. They also have to understand, these two, but they also have to understand what default things you've put on your network from a naming querying standpoint. As an example, does anybody have a Mac here? A lot of us. Well, when you get onto a network, Apple's been kind enough to add Bonjour. So it provides a different type of naming. So bad guy, you only have IPv4 DNS. Well, I can falsify using Bonjour that I am your v6 default router or anything else. Kind of a problem, right? So your SOC needs to understand, and there's 8 major naming systems based on the operating system. They need to understand which naming system they use so they can start looking for attacks based on that class of malware, that class of other things. They also have to look at their forensics tools. Many of the forensics tools don't represent IPv6 correctly. And again, a lot of SIMs have problems both in translation and representation and analytics for IPv6. So there's a lot of good work that can be done here. But from a practical standpoint, those 4 steps will get you very far. Do the inventory, ask the hard questions. How do you represent your data as you're moving to that next list? How do you do your analytics? How does your SOC engineer interact with those tools? Those are what has helped some of my customers succeed. And yes, I was going to make it a 12-step program. I could call it the IPv6 12-step program, but I felt like that would have bad ramifications.
Hi, my name's Kurt, and I'm an IPv6 engineer.
Yes. I knew somebody was going to do that.
So, Joe, I'd like to get your thoughts on what SDN might mean for both an attack and a defense perspective.
It's a unicorn from a defense right now. It's a wonderful unicorn. Oh, I'm sorry. No, it's the other. At Black Hat this year, they demonstrated specific vulnerabilities. There's a really good video out there on attacking SDN. There's actually 2 of them. One of them was pretty lightweight. Go out and watch that video. Get your SOC engineers to take a look at that video. A lot of things are things like the control channels aren't encrypted. The certificate is self-generated, therefore you can't validate where that certificate came from. No encryption at all on some things. No validation of man-in-the-middle attacks. So there's lots of little issues that we're working through with the SDN. Long-term for SDN could be a big benefit to the security community once 1.4 gets implemented and the North Bus actually has a usable interface that could be applied to security products. Then it becomes very cool. We can then start looking at the way we do defense differently. But today, because of the pushback from the vendors to implement only 1.3, we're really not seeing that capability of interfacing security functions unless you want to write a separate application for the 5 major SDN versions and then do the troubleshooting against that, which I haven't seen anybody that wants to do right now.
Any other questions? We still have a few moments. All right. Well, Joe, thank you very much.
Thanks.